In this segment, I'm going to describe the API gateway pattern. So the problem that it addresses is this: how do clients of the system interact with the microservices that make up the system? If you think about it, in a monolithic architecture, there's really one thing that exposes some HTTP endpoints, and it's very clear who a client should talk to. But in a microservice application, you could have tens or hundreds of services, and in that case, which one of those services or should that client talk to, or should it be all of them? You know, there's some very, very interesting issues there. So the example I like to use is actually the Amazon product details page. So you can imagine here the client is an application. It's a web application that renders this page. It has to gather various pieces of data from various microservices in order to render that page. So it has to get the basic product info. It has to get the reviews, the recommendations, the sales ranking, and so on. So that actually there's many, many different little snippets of data that it has to gather in order to render this page. There are various forces or issues that you need to address when designing how clients of an application now interact with the microservices-based application. Typically, there is a mismatch between the fine-grained microservices and the needs of a client. So the client that's rendering a web page just needs a whole ton of data about a product, right? But that data is split amongst a whole set of services. So the review service has the review data, the recommendation service has the recommendations, the product info service has the product info. So the data that the web application needs is just spread around tens of different microservices. What's more, different clients could very well need different data. So a web application that's rendering a browser page could actually need a lot more data than a client that's running on a mobile device that has a small screen. So it's like different clients need different data. There are also differences in terms of network characteristics. So for instance, a web application that's running on a LAN has access to a network that's got much higher throughput and much lower latency than an application that's running across the internet, a WAN, or a mobile application that's having to use a mobile network. So the actual network characteristics can vary quite differently between a LAN and a WAN and a mobile network. Also, the number of service instances and their network locations, their IP addresses and their ports can change dynamically. Every time you take down a service instance and create a new one, it could very well be running on a different host and a different port. And if you're auto-scaling, then the number of instances that you have could change very dynamically based on the load. So it's a very dynamic, it's a very fluid environment. And then also, the actual partitioning of the system into services can change over time. You might decide to take a service, split it into two. You could decide to combine two services into one service. And you really want to be able to hide that from the clients. Quite often, the clients could be on devices that you have absolutely no control over, and you can't force them to upgrade in lockstep as your system evolves. So you need to keep that encapsulated. So here's an example of the situation. So on the left, you've got both a traditional server-side web application that's accessing the microservices on a local area network, and then you also have a mobile client. Might be some JavaScript running in a mobile browser, or it could be a native app, and it's accessing the application over a mobile network. And then the application itself is comprised of various microservices, some of which have a REST interface, and then some others could actually have a non-HTTP interface. In this case, I actually picked Thrift, a TCP binary protocol. So one option for communication is that the clients just talk directly to the microservices. And there's a bunch of issues with that. Number one, the API could be very chatty. So to actually gather the data to render a product details page requires making requests to numerous back-end services. For the traditional web application that's running on a LAN, that's probably not an issue. But for the mobile client that's using a mobile network, that probably is not going to work too well. Another issue you have is that some services can expose protocols that aren't friendly to the web. They don't really go through firewalls, and so you can't actually access them across the internet. So that can be a big issue. And then also there's just the more fundamental issue of what's the IP address and port of the service instances that you're trying to access. So there's some real interesting practical problems that you have to solve if you want to actually try and talk to microservices directly from a client. So in fact, a better solution really is to use the API gateway pattern. And the way that works is that you have a service that acts as a single entry point into the system. So the clients all talk through it to the various microservices. It exposes a nice REST API, and when a request comes in, it can, in a simple case, it can forward it to the relevant microservice. But it can actually do something a little more interesting. It can actually provide each client with a client-specific API. So for a web application that's running on a LAN, accessing it locally on a LAN, it could just provide a sort of chatty interface that maps one-to-one with the microservices. That's okay, but for a client running on a mobile device, it could provide it with a coarse-grained API, such as give me the product details, which it handles by making a request to all of the back-end services, aggregating the response, and passing it back to the mobile client. So the mobile client only has to make one round trip, which is a vast improvement if it's using a mobile network. And then another thing that the API gateway can do is protocol translation. So it can translate between the web HTTP world and whatever protocols are being used internally. Another great example of that is perhaps internally there's a message broker that's using AMQP. The API gateway can translate messages into WebSocket messages that can flow into a browser, for example. A good example of a company that's taken this approach is Netflix. So rather than providing a one-size-fits-all API to all of their streaming clients, I think there's probably like 1,000 different streaming clients now. What they decided to do is, in what you could consider to be an API gateway, they run client-specific server-side code that provides each client with its own custom API that's well suited to the needs of that client. And then when a request comes in, that gateway code actually translates that request into calls to various back-end services. And if I remember correctly, it was sort of like one request comes in and it fans out into 7 different calls to back-end services. It's worth reading. Just go check out this article on the tech blog. So that's the API gateway pattern. There's a whole bunch of benefits. It insulates the clients from the partitioning. The client just sees the API provided by the gateway, and then the gateway has code that knows about the partitioning. It insulates the clients from having to know the network locations of all of the service instances. That's just handled by the API gateway. It provides an optimal API for each client. That's good. It makes the client simpler. It means that the API is suited to the network that the client is using. And typically what that translates into is reducing the number of round trips between the client and the server, which matters over a mobile network. And it also simplifies the client by moving logic to make multiple requests into logic that makes a single call to an API gateway where there's logic that does the fan out. And it also translates between web unfriendly protocols to the HTTP-centric web protocols. There are some drawbacks. Number one, there's increased complexity. You have to operate and maintain this API gateway, which needs to be highly available and so on. You know, it's yet another moving part within your architecture. And it does increase the response time slightly because there's an extra network hop introduced by having to go through the API gateway. So even though there are a few downsides to the API gateway, I think it's something that you should always seriously consider using in a microservice architecture because of the benefits that I outlined earlier.